Hello, and welcome to Nerdsniped, presented by Seedplex. Nerdsniped is a series of advanced blockchain topics that interest me that I'll be covering on this channel, starting with Arcium. Arcium is a new privacy protocol that is built on top of Solana as a network extension that I'm really excited by. A lot of people have heard about it, but as I bring it up, I realize that not a lot of people understand how it works and are missing the kind of basics of why it's so cool, um, which is my hope that I can educate a lot of people about why we are building on Arcium at Seedplex and why it's one of the most interesting and promising new technologies in the blockchain space today. So let's get started with what is Arcium? It is the secure execution of any computation on fully encrypted data. Arcium is a MPC network, multi-party compute network, that works as a network extension on top of Solana. What that means is Solana acts as a data availability layer. The data that Arcium interacts with stays on Solana, but the compute can happen off of Solana on its Arcium's compute network. Um, the really cool part about this is that because Arcium is doing fully encrypted compute, it's encrypted, it's doing all of the computations with encrypted shares. It doesn't actually, none of the nodes actually get to see the data. It can be a permissionless set of nodes. It's a mathematical circuit that gets, broken up into the data getting processed by it gets broken up into a lot of different pieces. And so no single node is able to decrypt or see that information. The other really cool things about Arcium being a network extension instead of being its own L1 is that it gets to tap the massive liquidity that exists on Solana currently. It doesn't have to bootstrap liquidity. It doesn't have to bootstrap a node network that does consensus and all of these things. The Solana can handle all of the transaction processing. And as transactions come in and they request compute, it goes off to the Arcium network to do that encrypted compute, to do all those interesting things, and then send the data back after it's done in a callback. The other really exciting part as a developer for me is as I've been playing with the Arcium tooling, it's not just mathematics, it's not just really brainy stuff that PhDs get. As a developer, you can get your hands dirty today and build something interesting and exciting with their tooling. It's very, maybe not beginner friendly, but very Solana developer friendly. And I am excited to see what you guys all get up to in building. So let's chat a little bit more about how Arcium works. So we mentioned that it was secure computation on encrypted data. Um, what that means is that, as I mentioned, Arcium nodes never get to decrypt the data that is sent to them. So when a transaction comes in, it might either have encrypted data or it might say read from encrypted data off of this account or anything like that. That data is broken up into encrypted shares and then split amongst all of the nodes that are processing that instruction. And so no single node is able to actually understand what that data is. It's doing computation on a mathematical circuit, not necessarily the code that you wrote. The code that you wrote gets compiled down to that mathematical circuit. Now, why is this really cool? Because there are some competing technologies that also do encryption and this kind of computations, right? For example, a lot of folks probably heard of zero knowledge proofs. ZK has been big in the blockchain space for years now. And client-side proving is getting better and better and better. So a lot of people might be wondering, well, why do we care about MPC? Why do we want to do compute on other nodes? Why don't we just do this on the client side like we do with all the other ZK tech? Well, there are a couple of drawbacks to ZK. First, if you're generating proofs on the client, that means that you are kind of throttled by the compute on your client, whether that's your phone, your laptop, etc. And that means that if you have a slow computer, the proof generation time on ZK is going to be fairly long. That is being worked on. There are lots of improvements in client-side proving, and we're hoping to see more and more and more of those. But the second problem is that the design space in ZK is fairly limited. No matter how good proving times get, trying to do computation on two sets of data is really hard because when you have like this kind of concept of what Arcium calls privacy 1.0 versus privacy 2.0, privacy 1.0 being your own state is encrypted, like your own data is encrypted, only you see your data, and privacy 2.0, which is you can do compute over encrypted data across multiple parties. ZK can't do that second part. So when you or like to make enable that requires significant overhead, which kind of breaks the design space completely. You know, if I have an encrypted token account, you have an encrypted token account, and I want to do a order matching system or like any kind of complex computation on these kinds of services, suddenly it becomes really, really hard to do with ZK. With multi-party compute, because of the type of cryptography it uses, you're not submitting proofs, you're submitting encrypted data, which is then turned into encrypted shares and then processed over multiple nodes. A couple other technologies that people might have heard of are FHE and TEE. FHE stands for fully homomorphic encryption. It's a promising technology, but it requires really beefy, expensive nodes. And the challenge with FHE is that not only does it require those expensive nodes, it's just significantly slower than the MPC protocols that we have available today. I think when I was talking to Yannick, he's mentioned that the protocol that Arcium uses for MPC was able to do something like, I think, 16,000 times faster than the most modern FHE protocol. Maybe that number is a little off. Yannick can correct me if I'm wrong. Even on commodity hardware, right? And so that's a massive, massive, massive speed difference. The other great thing about MPC is, again, it's commodity hardware. Anyone can join that node permissionlessly. Now, there's probably a lower bound on that commodity hardware, just like we have with Solana nodes and whatever else, but it's still, approachable versus FHE nodes, which are significantly more expensive. And then finally, the last technology that someone you might have heard of for encrypted computing is trusted execution environments, which are secure enclaves. The challenge with these is that they require specialized hardware and they need physical security. Most often, when you're using trusted execution environments, you're using them in a cloud hosted environment like Azure or AWS, where those big companies are taking care of the physical security of those of that specialized hardware. So, we want anyone to be able to run a node. We want permissionless decentralized approaches. So with that in mind, I think MPC is currently the best what we got of what we have when it comes to encrypted compute and encrypted data. So what does it mean for it to be a Solana network extension? So Arcium being a Solana network extension means that when a transaction comes in, when you write a program, you're writing kind of two sets of instructions. The first set of instructions are what live on the Solana blockchain. They can be any Solana program. And then as part of your Solana program, you might have an instruction that says, actually, I want to send off this piece of data and this piece of compute into the MPC network to compute, and then get a call back when it's done doing the thing that I asked it to do. So that's the second set of instructions that you're writing, which is instructions that go on to the MPC network and then actually get turned into circuits and processed within that network. Again, the really cool part about this is that because the base layer is Solana, you have all of the liquidity and composability with existing programs. You want to use Radium as your AMM, you want to use DeFi Tuna as your AMM, you want to use any kind of the program that exists on Solana today, or you want to use the liquidity that is available on Solana and do crazy things where you do some kind of encrypted compute and then you do a regular transfer and then you do a confidential transfer. All these things are possible because Arcium's built as a network extension rather than its own L1. If it was its own L1, we would have to bootstrap liquidity on Arcium. We would have to bootstrap consensus and all of these things with sufficient nodes, and that's really hard challenges. So rather than that, Arcium said, let's focus on doing what we do best, which is encrypted compute, and let Solana handle the liquidity problems, the node and consensus, and all of these other things. And so fundamentally, it's a tooling that adds so much more design space onto what can currently be done on Solana. So let's do a case study, right? So my startup, Seedplex, that I'm building with my co-founder Tregs, um, builds venture tokens that blend the best of equity and token fundraising for founders. Um, the problem is if you have institutional finance like venture capitalists, they don't necessarily want to park large funds in public positions. They might have 1 million to 5 million, or whatever amount of money to park in a venture deal that will sit for 5, 10 years, or they want to make it liquid or do any number of things with it. But they don't necessarily want their positions public. They don't want um, their P&L to be public, or if they're trying to do OTC deals or anything like that, they want some level of protection and privacy. Well, we couldn't really offer them that on Solana until today, because now we can do it on Arcium, which we're very, very excited by. This is just one of the many, many, many different case studies that we can cover in later videos, because the design space of Solana has just like tripled or quadrupled with all the cool stuff you can now do. With that, I hope you look forward to future videos. They'll be uploaded on this channel and on Twitter. If you have any questions, feel free to reach out either to me, or if you're looking for help with Arcium. Arcium has a great Discord, and they have a developer channel for developer questions. You can always hit up any one of their team members, and they're super helpful, super nice people. Love working with them. Can't talk about them enough. They're great people. So hopefully you learned something. Hopefully you watch future videos. And if there's a specific topic that you want me to deep dive into, feel free to comment that below. And hopefully I'll get to it in a future video. Cool. Thank you.